Sir, good morning.
Good morning, sir.
ओके स्क्रीन एंड ऑडियो क्लियर है स्टार्ट करें
Yes, sir.
all right so today we are going to start the next unit number 4 so let's discuss first the content of the unit 4 first we will look introduction to operating system then system softwares overview of operating system then introduction to scheduling function of compiler interpreter linkers loaders and cross compilers which runs over multiple operating systems. So this is the content of unit 4. So let's start today's lecture basics of operating system. If you look at the first statement about the basics of operating system is considered the backbone of computer. Now the question arises why it is called the backbone. Like the human body, the backbone is very essential. It handles all the body parts. Similarly, in the operating system, there are number of applications. There are number of application software, programming softwares. So all the application software, programming software handled by operating system. If computer system does not have any single operating system, then it could not able to perform any applications or any program. So operating system is considered the backbone. That means it indicates that it is very essential part, essential system software for the computer. That is why it is called backbone of computer. Second point about the operating system is it manages both software and hardware. Means all the applications which you want to run, it required operating system first. The base system is operating system. Then over the base system, we can install number of application software. So it manages all the softwares which are designed for the specific purpose, right? And it also manage the hardware resources. Like if you want to take a printout of your document file, then it required printer for performing the printing job. So operating system will manage the hardware resource. Similarly, if you want to get the scan copy for the scanner from the scanner, so it manages the scanner also. If you are interested to work with the light pen, joystick, mouse, keyboard, any other hardware resources, it may be input devices, it may be output devices, or it may be network devices. So any kind of hardware devices which are related to the computer, it manages by the operating system. That's why this statement indicate it manages both software and hardware resources. So without operating system, we cannot run any software as well as we cannot access any hardware. So once we installed operating system, we installed all the driver software related to the hardware. Then operating system recognize all the hardwares and hardware can be accessible for any program. In the third point, operating system are responsible for everything from the control and allocation of memory to recognize input from external device and transmitting output to the computer display. So third point indicate that if you declare any variable in the programming language, suppose you declare in this way, you are writing a C program and you declare age equal to 20, something like that. So allocation of memory for this variable is responsibility for operating system, right? So operating system is responsible for everything from the control and allocation of memory to recognizing input from the external devices. Because you are typing, you are giving the input from the keyboard, and when you declare any variables or when you're giving any input, so you take a memory in the in the computer system. So the allocation of memory is solely responsible for operating system. Only operating system is responsible for allocating the memory location for any input coming from the external devices. Now fourth point, it creates interface between user and hardware. Operating system does a lot of things for the user. It creates interface between users and hardware. Suppose me as a user want to access printer. Printer comes into the hardware category and me consider as a user, and you also consider as a user. If you are using your laptop and computer or tablet, everything must have a single operating system. So there are two kind of persons in which the operating system works, users and hardware. User want to access the hardware. That means there must be an interface between the user and hardware. So this interface is created by the operating system. An interface is created by using the driver software. You know very well, if you want to take a hardware from the market, that hardware does not recognize directly with the operating system. So you should install the driver software related to the hardware. And once you install the hardware driver software in a computer system, operating system will start recognizing the input devices and output devices as well. So installing the driver software creating the interface between user and hardware. That's why the fourth point indicates that it create, that means operating system creates interface between user and hardware. Now let's talk about the point number 5. It is system software that manages computer hardware. We know that operating system manages the hardware as well as the application software. But it is also comes into the category of system software. Basically, there are two types of software, application software and system software. So application software are solely designed for the specific purpose. Like if we want to make a document file, then MS Office provide me MS Word. This is one kind of application program. Suppose I want to make some tables and reports file, then Microsoft provide me application called MS Excel, right? So this is designed for a specific purpose. So it is called the application. Like right now I'm working in a document file. So I open my Microsoft Word file. So this software, this application software provide me support for writing the document file. But I cannot make a PPT here. I cannot make a Excel here. Right? It is not a user friendly for making the PPT and Excel and calculation as well. But it is capable for doing documentation file, documentation work. So it is a application software. But all the application software required some essential plugins which provide by the system software, like operating system. So always there must be a single operating system, single software must be there in a computer. Then you can have a number of application software as well as programming software also. So operating system comes into the category of system software because all the application software handled by the system software, which is nothing just a operating system. So it is a system software that manage the computer hardware. It is a set of program that manages the resources of computer system, provide environment where user can execute other programs. So what does the system software actually? It is nothing, it is a set of program. First of all, we should know what is system software. So it is nothing, just a set of programs. And each programs does something for us. So it is a set of programs. What it does, it manage the resources of the computer system and provide the environment where user can access, execute the other programs. That is why it is very essential we must have a single system software in our computer system. Now, 6th point, the major aim of operating system is to use the computer system resources more efficiently. You know, if we install the operating system, Windows operating system, then we can use any resources of the computer efficiently. If we have a greater RAM size, primary memory size, we can run a larger program, larger application, larger games very quickly. So operating system, the major aim of the operating system is to use the computer system or a resources more efficiently. Some operating system provide the support for use the effectively use of hardware, but some operating system does not provide. It is totally based on command. You know very well, the Linux is one of the example, which having some GUI also, but it is the most working style based on the command line. So the major aim of operating system is to use the computer system or resources more efficiently. Now, 7th point, operating system as a resource manager, because it handle the resource, the allocation of resource and decline the resources is solely dependent on the operating system. If any process, any program requires some hardware resources, then operating system is responsible for allocating that hardware to the process or a program. As well as once the program has finished their task, the declaiming or releasing the resources is also responsible for the operating system. So it handles the resources. That is why it is called resource manager. So resource manager does a lot of things. For example, keeping track of all the resources. That means enforce policies that determine who get what, when, and how much. You know that the every software or application software does have some policies how they work. So the enforcement policy is determined by the operating system, which software and which hardware access how much by the user. Now the allocation of resources is also responsible for operating system, which resource is required for which program, that is determining by the operating system first by using some algorithms. Then it provide wisely hardware to the resources, hardware to the programs. Then as well as reclaiming of the resources is also done by the operating system, because once the program have completed our task, the resources must be reclaimed or released by the program. Otherwise there may be a condition arises called deadlock. That means we have a number of requests but we do not have a single resources to allocate to the process. So The allocation of resources is responsible for operating system. Similarly, deallocation of the resources is also responsibility for the operating system. Now let's some example. The most popular example of operating system: Windows, Linux, Mac, DOS. The most popular example of operating system, we can category we can define the two category. One is command line command line operating system, which based on command directly, like Unix and DOS. And second one, we can define the category like graphical user interface based on GUI. Based on GUI, we have number of operating systems here. We can go with the Windows operating system, and Windows operating system, we can have number of brand and number of versions, like Windows 2000, Windows 2003. Then the next version comes 2005, 2007, 2008. These are some versions of Windows. Then NT, then Millennium, Windows NT network for supporting the network activities, Windows NT, Windows ME, Millennium, Windows XP. Then comes the new version XP, and XP have a lot of versions: SP1, Service Pack 1, Service Pack 2, Service Pack 3, and so on. And etc. Then, latest is Windows 7, 8, and Windows 10. These are some version or system software name. And suppose if we go to the Linux operating system, it is also a GUI based operating system. Linux can have a number of system software with version, like Red Hat. You listen the Red Hat 5, 6, 7. Latest Red Hat version is 8.3. Now another Linux is Fedora. Updated is Fedora 19. Similarly, SUSE operating system. You know the name Ubuntu, which is the UK product based on Linux. You already heard the name of Kali Linux, which is very popular for cyber security and ethical hacking. So Red Hat, Fedora, SUSE, Make, Ubuntu, Kali Linux. Cent OS. So these are a variety of Linux operating systems present in the era. We can categorize into different way Windows operating system and Linux operating system. So in Windows operating systems, we can have a number of number of versions available in the market. So based on our requirement, we can purchase any one, or there are pirated version is also available in the net. So we can download from there. And second one is Linux. We can go with the Linux operating system. It is also a GUI based. So Red Hat version 5, 6, 7, 8. Latest is 8.3. You can go with the Linux Red Hat Corporation, and you can download by making your account in the Red Hat website. Fedora, SUSE, Mac OS, Ubuntu OS, Kali Linux, Mint, CentOS, and many other more. So these are some name of operating system which is very popular nowadays. Windows can have a single user and multi-user, and Linux is mostly used for multi-user environment. So if a single user access operating system directly, it called the single user operating system. And if more than one user access the resources of the computer, it is called multi-user operating system. So multi-user operating system basically designed for the purpose of serving something. So if you want to make a server, we should go with the Linux. It provide a better security as well as the support of the applications and support between the application and users. And all the maximum IT industry is based on Linux. It has a Linux server for security purpose. So these are some examples of operating systems. Now, operating systems objective. So let's discuss the next topic. Till now, what we had discussed, we are discussing about the basics of operating systems, how we can define the operating system in various way. We have write something 7 point. So if question arises what is operating system, you can choose any one definition from the 7. And this is the examples. You can take any one or two examples for making your definition proper. Now, operating system, the objective of operating system. Why we need to design the operating systems, right? So this is the objective. If we have some purpose, we start designing something. But if we do not have any objective, then we need not to design a software. So similarly, the objective of operating system, the three major objectives of operating system is convenience, efficiency, and ability to evolve. So convenience means provide a high level abstractions of physical resources. That is the objective of operating system. It provide high level of abstractions about the physical hardware. What does it mean by the high level abstractions? That means we directly use the keyboard for giving the input, but we do not know the actual mechanisms how the input is sensed by the operating system. If you press, let's suppose if you press A by using the keyboard, then how many signals goes to the operating system and how it is recognized and making the A. So this is called the high level of abstractions. We just press the button and we see in the monitor on the monitor that what we have pressed in the keyboard, but we do not know the internal mechanisms This is called the high level of abstractions. So operating system must be designed in this way, in such a way that there must be a high level of abstractions based on the physical resources. Similarly, the second objective is enable the constructions of more complex system. Right? We should authorize to enable the constructions of more complex software system. Like Linux is open source operating system. It provides the entire code of their kernel and it is totally free available in the internet. So if you have the expertise, if you want to customize the kernel of the operating system, which is the core part, so you can do. So it is the enable the construction of more complex software system. Enable portable code. That means number of port is available in the operating system. So every port must be enabled by the operating system and every port do something for the user. Right? So this is called enable portable code. So this is called the convenience. That means by using 3 point, we just make the convenience process. That means if you want to access any hardware resources, we should not we should know how to access the hardware resources. Now second is efficiency. It provides efficient and effective user interface. If user interface is effective, definitely the operating system will efficient for the user. And operating system control how processes may access the resources. So this is also makes the efficiency of the operating system. Shared limited or expensive physical resources. So if we have some physical resources, operating system allow us, we can share the resources in the network, because we cannot attach printer with individual computer system. We can share the printer in one department. So if we have two department MBA, MCA, we can have only two printer and we can work properly by using two printer. So operating system provide a shared facility for limited or expensive physical resources. Optimize performance, that means operating system uses a number of applications to run. Operating system can have a number of processes and each processes have some performance. So if operating system perform a number of processes in given time, it makes a greater optimized performance. So optimized performance is nothing just a throughput. If the operating system perform number of processes in the unit time, it called optimized performance. It also provide protection. So these 5 points provide the efficiency, how to build efficiency by using operating system. Now third is ability to evolve. That means as operating system should permit the effective development, testing and introduction of new system function without interfering with services. We can take example like operating system in multi-user environment, there is the operating system called Linux. So Linux having the entire source code available into the net. So if we have some different idea to customize the kernel, so we can do the customization. We want to test some modules, we can able to test that module because it is freely available into the net. So these are some objectives of operating system. Now the third point is functions of operating system. So again, there are a lot of functions which is being performed by the operating system. First is initial loading of program. Second one, process management function, memory management function, device management function, file management function, secondary memory management function, network management function, protection and security management function, command interpretation function. So these are some broadly category of function of operating system. So one by one, we will look at. First is initial loading of program. So what kind of programs it initially loaded? So let's talk about some initial programs which are being loaded by the operating systems. So initial loading of program, that means the loading of kernel. So first question arises, what is kernel in operating system? So kernel is the core part of operating system, which is responsible for creating the GUI environment. So whatever the GUI environment you are looking in this computer, this is designed by the kernel, right? So this is called graphical user interface. If you see some icon on the desktop, taskbar, start symbol, date and time, and many more things. This is a graphical user interface which is designed by the kernel. So kernel, the core part of operating system. So loading of a program, initial program, that means we are talking about the kernel programs which are loaded firstly whenever you start your computer. So after performing the booting process, the kernel will load into the primary memory, and it will load with some essential file which is responsible for creating graphical user interface as well as the collection of commands. So for accessing any applications or any hardware resources, we basically required two things. First is graphical user interface, and second one is collection of commands. So if we have two collections, we can access any applications or any hardware connected with the computer. So let's talk about how GUI is designed. So for creating or designing the GUI, graphical user interface, kernel required some files like io.sys, input output system files, which control the input output devices. So it contains all the files related to controlling the input output devices. Second important file is ms-dos.sys. It will load the internal or external commands collection. We can say it loads ms-dos. You know very well, if you are using the graphical user interface, as well as there must be a single operating system called DOS, which is inbuilt in the operating system, right? And you can go by clicking the start button and command cmd, and you can access the command prompt. So what it indicates that DOS is also available in any time. and GUI is also created. That means we have allocated both the things by kernel. So GUI is designed by using io.sys, config.sys, and auto executable.batch file, and the collection of command given by the important file known as msdos.sys and command.com. So these are two files. Let's mark it: configuration.system, auto executable.batch. So these are three different files which are essential for designing the graphical user interface. And ms-dos.sys and command.com. These are two essential files which contain all the internal and external commands. By using, we can interact with the process, we can interact with the hardware resources, we can interact with the application programs. So graphical user interface and collection of commands. In order to complete this task, the kernel provide a various files. So these are the files which is the actual content of the kernel. So when we are talking about the booting of the operating system, actually we are loading the kernel in the primary memory. And the loading of kernel indicate we are loading some files: io.sys, ms.sys, config.sys, command.com, auto executable.batch. io.sys, the purpose of io.sys is it is used for controlling the input and output devices. ms.sys, it load the MS-DOS, Microsoft System Disk Operating System. Microsoft Disk Operating System. Config.sys is responsible for configuration of device driver. Command.com load the command line interpreter. Auto executable batch file sets the procedure the user wants to perform the PC to perform automatically when it is booted. Because you can execute any file, so this file will run. So that is the first function of operating system. What it does for the user, it loads the initial program for the user, which is called booting process. So loading of kernel is called booting process. And the booting process, what it does, it loads number of files into the primary memory and provide the graphical user interface, and it provide also the collection of commands. So let's talk about the second function, which is called process management function. Operating system manage a lot of processes created by the user. If we are running doc file, it is also a one kind of process. It has also a process ID. It also required some memory, and it also required some CPU clock pulse. Similarly, I can have a number of applications in our taskbar. Like I'm using Microsoft Teams software, I'm using doc file, I can use the internet also, I can use the Paint application also, right? That means if you open a number of document file, number of applications, each application become the process, and all the process is managed by the operating system. So program at the time of execution is called a process. We can define the process in this way: program at time of execution is called process. So you create some program by using editor or IDE like Turbo. So when you save the when you save your program in the hard disk, it is a program. But when you execute that program, it comes from the hard disk to the primary memory. Then it becomes the process. So there is a very slightly difference with the process and program. Program is a passive entity which is stored somewhere else in the hard disk. But the process is active entity stored in the primary memory. Program having the pages which contain the information about the program. What is the content of program? So content will store in the pages, but content of process is managed by the frame. Program is stored in the hard disk, process stored in the primary memory, which is called RAM. Second one is batch job is also kind of process. If we have a similar process, like we have a 5 job related to the printing, then we can make a batch for this related process, and we provide the batch number also, right? So in the next lecture you will study about the batch operating system. Then you will get to know how batch operating system works. What is batch actually? So right now you just understand batch job is also kind of process. That means a related function performed by the process, we can make a batch also. So if we have a 5 process or 10 process which is required for printing job, so we can assign one batch number to 10 process. A time shared user program is a process. A time shared user program is a process. A system task such as spooling output to a printer also is a process. Like if we give some task to the printer having also some buffer which maintain the task in spooling. That means the task is waiting for the hardware of printer. The task is waiting for the printer is maintained in the spooling. Spooling is nothing, just a buffer of the printer. It is just like a queue. For example, suppose there is a multi-user system. Each user can perform their own task. Each task become process situated at RAM. So at the time of execution, there must be number of processes maybe in the primary memory. So somehow we need to manage all the process at any cost. Operating system do favor for us. It manages all the processes with respect to their policies. So this is example which we have taken to understand a system task such as pooling output to a printer also a process. And similarly, we can have a number of processes in the primary memory also. Each process having different text region, stack region, data region. Every process managed by individually by the operating system by providing the process ID. So that was the second function of operating systems. So in the next lecture, we will discuss the next function of the operating system, which is memory management function, device management function, file management function, secondary memory management function, network management function, and protection and the security and command interpretation function. So the rest of function we will discuss in the next lecture. Till the end, if you have any doubt, you can ask any query. Do you have any doubt?
No, sir.
Anybody have any doubt?
No, sir.
Okay, so that's all for all the lecture. Thank you so much.